If you looked at the clear night sky with the naked eye, which planets would you be able to see? Technically, you could see them all at some point except for Neptune, the smallest of the gas giants and also the farthest. It's a place that puzzles. You might think that a planet so far from the sun wouldn't have a dynamic atmosphere with gigantic storms and extremely fast winds. So why is this planet so interesting? Today you will discover everything you should know about Neptune. Before continuing, remember to subscribe to the channel and activate the bell to not miss any videos and to support the channel. Let's start from the beginning. Neptune is the only planet discovered thanks to a mathematical prediction. When Uranus was discovered, astronomers plotted its orbit and noticed that Uranus did not follow their models. From Uranus's perturbed orbit, Urban Le Verrier concluded in 1846 that there must be another yet-to-be-discovered planet in a specific position. Surprisingly, Johann Galle was able to find it only 1 degree away from the predicted point. Triton, Neptune's largest moon, was discovered a few days later. However, Neptune remained little known because its distance from Earth and its very small apparent size made it difficult to study with ground-based telescopes. Only in 1989, with the arrival of Voyager 2, a huge amount of information about the planet became available. Suddenly, we could see what the planet looked like, confirmed the presence of planetary rings, and discovered many previously unknown moons. But let's come to today. What do we know now about this planet? Since Pluto was downgraded to non-planet status, Neptune is the 8th and farthest planet from the Sun. It is located about 30 astronomical units from the Sun on average, which means it is 30 times farther from the Sun than Earth's orbit. These astronomical units correspond to 4.5 billion kilometers, and from this it is understood why a space probe using current technology would take 13 years to reach Neptune. 4.5 billion kilometers is a considerable distance. Because of this long orbit, it takes a full 165 years to orbit the Sun once, meaning we have seen only one Neptunian year since its discovery. This distance from the Sun means that the average temperature of Neptune's atmosphere is very cold, -201 degrees Celsius. Its axial tilt is 28 degrees, similar to that of Earth and Mars, which have 23 and 25 degrees respectively. This means it has seasons similar to those on Earth and Mars, with the big difference that these 4 seasons each last 40 Earth years. At the moment, the Southern Hemisphere is experiencing summer, and during this summer, the Southern Hemisphere has become brighter due to interactions with the Sun. It's strange because you might think that with the Sun being 900 times dimmer on Neptune than on Earth from that distance, it wouldn't have a big impact. But even if the impact is minimal, it is still notable. And it is thought that the illumination of the Southern Hemisphere is due to the heating of the Southern Hemisphere by about 10 degrees C compared to the rest of the planet. This comparatively higher temperature has released frozen methane gas in the stratosphere, while elsewhere on the planet it remains frozen and is found deeper in the troposphere. To recap the layers of a planet, the troposphere is the lowest atmospheric level, followed by the stratosphere. Above these layers are the mesosphere, thermosphere, and finally the exosphere. This is a very interesting topic in itself that we will keep for another video. If you look at Neptune's climate, you notice that this planet has the highest wind speed of any other planet. The wind speed blowing westward at the equator reaches the astonishing figure of 2160 kilometers per hour, almost a supersonic flow. Interestingly, most of the wind travels retrograde to the planet's rotation. Colossal storms also form on the planet. When Voyager 2 passed by the planet in 1989, it saw the Great Dark Spot, a storm as big as Earth moving through its atmosphere. It also saw a smaller storm called the Small Dark Spot south of its larger sister. As Voyager 2 approached Neptune, this smaller storm changed hue from dark to light. When Hubble was launched, astronomers were curious to see the fate of these storms to understand if they were a permanent feature like Jupiter's Great Red Spot. But when Hubble was pointed at Neptune in 1999, these storms were completely gone. Since then, storms have appeared and disappeared, as well as giant, bright, high-altitude clouds. So why doesn't Uranus, which is very similar to Neptune in composition and size, also have such a windy atmosphere? Don't get me wrong, even the wind speed on Uranus is high, but it doesn't compete with Neptune's and reaches only 900 kilometers per hour. All this can't be due only to interaction with the Sun and its seasons. There must be something else at play to explain the extreme weather. We've said that Neptune is the farthest planet from the Sun, so you might think it's also the coldest. But actually, Uranus is the coldest planet in our solar system. Neptune radiates heat from within, while Uranus radiates almost no excess heat. This could be because a large Earth-sized body crashed into Uranus billions of years ago, exhausting all its primordial heat. Now, the more active weather on Neptune could be partly due to this greater internal heat. But what is Neptune made of? Its internal structure and atmosphere are believed to be very similar to those of Uranus. Its atmosphere is composed of 80% hydrogen and 19% helium, with tiny amounts of methane. It is the methane that gives Neptune its blue color, although it is a dark blue compared to Uranus's cyan. Again, like Uranus, there is a liquid mantle of water, ammonia, and frozen methane surrounding the core. At the point where the core and mantle meet, the pressure is so strong that methane can break down, and under the pressure, diamonds form. These are probably not diamonds as we know them, but there could be an ocean of liquid carbon with solid diamond icebergs floating in it, and diamonds raining down from the mantle like hailstones. This is just a theory, though. It is thought that around Neptune's core, there are 7 megabars or 700 gigapascals, about 7 million times the pressure of Earth's surface atmosphere. The magnetospheres of the two ice giants also have similarities. Neptune's magnetic field is offset by 47 degrees from its axis of rotation. When Voyager 2 discovered this feature of Uranus, the first theory was that it had to do with its unusual axial tilt. But then it found the same thing on Neptune, which has a more normal axial tilt. So the current theory is that the magnetic field is not generated in the core, but rather by a liquid mantle with electrical conductivity, or that the mantle deflects the magnetic field from the core, giving it this strange offset relative to its axis of rotation. All planets in the solar system don't have a perfectly aligned magnetic field. Even Earth's magnetic north is different from its north pole. But only Uranus and Neptune have such a tilted magnetosphere. Let's step out a bit from Neptune and get to its ring system. Like all other gas giants, Neptune has a ring system, although very faint because it is not dense and is extremely dark. The rings are against the black background of space and are also far from the sun, making them very difficult to see. The known rings are 5 in total and are named after people involved in Neptune's discovery and research. The innermost is the Gala ring, very faint and 2,000 km wide. Next is the first bright ring, Leverrier, though it is bright and only 113 km wide. Connected next is the Lassell ring, a very faint band 4,000 km in diameter. On the edge of this ring is the Arago ring, slightly brighter than the Lassell ring and less than 100 km wide. Finally, there is the outermost and most sought-after ring, the Adams ring, only 35 km wide but one of the brightest rings. It is particularly interesting because it is slightly tilted and has bright arcs. These arcs have remained quite stable since they were first observed in 1980, while planetary rings are usually uniform. These arcs must be made of material clumping within the ring, but the reason for this is currently unknown. Finally, I would like to talk about the moons. Neptune has 14 known moons named after aquatic deities from Greek mythology. The most famous, and by far the largest, is the moon Triton, which actually contains most of the mass of all Neptune's moons combined. Personally, I think it is one of the most beautiful moons in our solar system. The most interesting aspect of Triton is that it orbits retrograde and at an inclination to Neptune's rotation, implying it is likely a captured object and not something that formed alongside Neptune. Triton may be the cause of Neptune's rings, as it has disrupted the orbits of moons, perhaps causing them to collide and break into what are now the ring's debris. Triton is larger than Pluto and has a thin atmosphere. Voyager 2 even saw faint clouds during its flyby of the moon. After Triton, the largest moon is Proteus, averaging 400 kilometers in diameter, as it is not spherical. The reason it is not a sphere is explained by past collisions with objects that have struck the moon, leaving these huge craters. The regular inner moons orbit around the rings, and some act as shepherd moons. The irregular outer moons are all captured moons. Some irregular moons orbit prograde or direct, and others retrograde. Neptune's outermost moons are Samete and Niso, and are the farthest satellites of any known planet. It takes them 25 years to orbit Neptune once. This is because Neptune has a very large Hill sphere. The Hill sphere is the sphere in which the planet's gravity exceeds that of the Sun. Neptune has such a large Hill sphere because it is very far from the Sun. For example, the Sun's gravity has less influence around Neptune than on the largest planet, Jupiter. Thanks for watching this video. Subscribe and activate the bell if you haven't already. Leave a like and comment on what you think of Neptune. See you in the next video.